Good morning, Year 10. Hope you had a great weekend. Not had too much in the way of work submitted for last week's work, which is on relative masses, which we're about to look at again today. So please, 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 if you are struggling with this, it is imperative that you email me because this is a very important skill as we move forward in this topic. So again, I've copied the workbook into this assignment, and this video will help you go through those first couple of pages. So all I want you to do today is the work that you have done. I just want you to mark it using the mark scheme that I've provided and I'm about to walk through, and then submit a photo of your marked work into the assignment. And if there are any issues, you being able to access the work or not being able to understand it, please email me directly and I'll get back to you as soon as possible. So let's have a look at the mark scheme then, and I'll do a couple of walkthroughs as well as to how those answers were arrived at. So just shrink the screen. So again, this first task, as we discussed last week, you simply had to work out what all these animals weighed in terms of teenage girls. So a teenage girl weighs 50 kilograms. So what do all these animals weigh? So if we have a look, let's look at the sperm whale for an example. Sperm whale weighs 40,000 kilograms. So I did 40,000 divided by 50, which is 800. So the sperm whale weighs 800 teenage girls effectively. More complicated ones down here. So this worm look weighs 20 grams, which is not in kilograms. So you can see the first thing I did, I was converted it from grams into kilograms. So how did you do that? Well, if I just zoom out a bit here, go down a bit, grams into kilograms, you divide by 1,000. So I did 20 divided by 1,000 to get to 0.025. Then I divided that by 0.02. Then I divided that by 50 and it gave me 0.004. Again, that's not really that important or an important skill for you to be able to use moving forward. These really are crucial. So again, I'm going to pick a couple of examples here of how do you work out this concept of relative molecular mass, or relative formula mass. You can see they all say MR. All right, if I zoom in a bit more. All right, MR stands for relative molecular or formula mass. Basically, they're the same thing. It's the weight of the actual compound that you're trying to work out. So let's pick a couple. Let's pick, how did I get this one down here? Oh, sorry, ignore that. How do we arrive at, let's go with SO3. Let's try SO3. So that one there. So apparently the answer is 80. Well, how did I work that out? Well, SO3 has got 1 sulfur atom and 3 oxygen atoms. So using the table at the top, what does sulfur weigh? Sulfur weighs 32 and oxygen weighs 16. So just have a go at that. 32, 16. So then 1 times 32 is 32. 3 times 16 is 48. Add them together, what do I get? 80. So I think that is the actual answer there, which was 80. Correct. So again, it's just adding up the weights of all the different atoms in a compound, and the more you practice, the better you'll get. This next one's quite interesting actually. Let's have a look at this one, this AlNO3 3, because there are brackets involved here. So AlNO3 3. So write down everything that we know. We've got 1 aluminium atom. All right, and remember, each capital letter is a new atom. So there are 3 capital letters in here. So there are 3 atoms in total. So we've got Al, we've got N, and we've got O. Okay. So how do we work out how many N's we've got? Well, there are brackets here. You see these brackets. I'll just highlight those. So you can see with those brackets. Okay, superb. Whatever's inside the bracket, you have to times by what's outside the bracket. So we've got 1 N just there, but there's 3 lots of these brackets. So whatever's inside, you multiply by the little number outside. So if there's 1 N inside, multiply by 3, there are 3 N's in total. And O's, there are 3 lots of oxygen atoms inside the brackets. Multiply it by the little number outside, which is 3. 3 times 3 is 9. And then using the numbers at the top of the sheet, so aluminium is 27, Nitrogen is 14 and oxygen is 16. So 27, 14 and 16. Okay, so you'll need to calculate for this. 1 times 27 is 27. 3 times 14 is 42. And 9 times 16 is 144. So if we add all of those together, you end up with 213. I think someone better check that. My maths. Yep. Sorted. So 213 is the relative molecular mass of this compound, which, is the correct answer. Let's try one of these ones down here then. So this is question 2. We're asked to work out the percentages of a particular compound element in a compound. So let's take 2E for example, because you're asked to work out the percentage of oxygen in AlNO3. Well, let's just work out this, because we can do this with what we've just done here. So we've worked out that the whole AlNO3 weighs 213. Our question is, what is the percentage by mass of oxygen in there? So of that 213, how much of it is from oxygen? Well, look at the calculation above. Which of these 3 numbers here was the oxygen? Hopefully you can all find that it's actually that number there. So the whole thing weighs 213. What percentage of that was from the oxygen? Well, it's 144. So to turn that into a percentage, we do 144 divided by 213 and then times it by 100. I'm just going to get my calculator just here. So 144 divided by 213 times 100 is 67.6%. Okay. So again, that's how you work out those questions. All right, just go through your answers, correct them. If you didn't quite get around to doing it, just fill in the answer and try and just show my working, because that will show you exactly how I did it. And the next page is pretty much the same. There are some quite complicated ones over here. So question 1, again, calculate the MR, and question 2, calculate the percentage by mass. So some of these you might actually have on the previous page, so just, don't do them again, just copy them down from this one. But let's try and figure out, let's do a complicated one. Let's do that one. Let's have a go at Q. So Q is Na2CO3 and 10H2O. So let's change the pen. So what have we got? We've got Na2CO3 and then it's .10H2O. So these compounds it's exactly the same before. You write down a list of all the different atoms you've got, but you can see there's this little full stop here in the middle of the compound. Now that just lets you know that this water over here is still part of the overall compound. So in the actual structure, for every one of these that you've got 10 water molecules. So what I'm going to do is I'm just going to work out these separate. Yep. So let's have a go then. So we've got 2 lots of Na. We've got 1 C. And we've got 3 O's. Okay. And on this side, so we've got H's and we've got O's. But how many of each? Well, you've got to take into account this 10 figure at the front. So I've got 2 H's there, but I've got to times that by 10. So what's 2 times 10? 20. And I've got 1 O there, but I'm going to have to multiply that by 10. So I've got 10 O's in total. And if I go to the top of the page, too far, should get my masses. So I need Na, which is sodium, which is there. I need C, which is carbon, which is there. O, which is oxygen, which is there. And I need H as well, which is there. So I've got my numbers that I need. Now I can write them in. So that's 23, 12, 16, 1, and 16. So 2 times 23 is 46, 1 times 12 is 12, 3 times 16 is 48. So all of that adds up to 106. And on this side, you've got 20 times 1, which is 20. You've got 10 times 16, which is 160. They add together to make 180. And then I'm simply going to add those two numbers together to give me the total mass. So 106 plus 180, 286, which hopefully is the correct answer on that particular one. Yep, there it is, 286. So again, it's the same thing. It's just good practice for you to do it and to go through the actual mark scheme to make sure. And the mark scheme hopefully is accurate. But if there are any problems where you think I'm not sure how Mr. Scrimshaw I got that answer, please let me know, because I do make mistakes every now and then. So we'll link in that question to part K then, which is asking us to work. 2K, which is asking us to work out the percentage of sodium in this compound. So let's just zoom out a bit. So we know that this whole compound weighs 286, and for question 2K we're asked to work out the percentage of sodium in this compound. Okay, so the whole thing weighs 286. Well, how much of that 286 was from sodium? So I'm going to have to find where sodium is up here. Well, I think you can find it's just there. Okay, so of the 286, 46 of it came from the sodium. So I'm going to turn it into percentage. It's 46 divided by 286 times 100. And I'll do it on my calculator. And you should get 16.1%. And then hopefully that is also the correct answer. 16.1%. Beautiful. So again, I want you to just make sure you really got this skill nailed down and that you can actually go through, attempt all the questions, check it with the mark scheme, and if there are any issues with any of them, please let me know as soon as possible, and I'll go through, and I might produce another video to explain how I got there. All right, shall we try one more just for parity then? Let's go into one from relative masses 4. So let's work out the percentage of chlorine. Let's do 2C. So it's Cl. So we're trying to work out the percentage of Cl in CCl4. Well, the first thing I've got to do is I've got to work out what does CCl4 weigh. So CCl4, there's 1 C and there's 4 Cls. And using the table at the top, carbon weighs 12, chlorine weighs 35.5. So 1 times 12 is 12, and 4 lots of that is 142. So add them together, you end up with 156. So the whole thing weighs 156, and we're asked to work out what percentage is chlorine. So if the whole thing weighs 156, how much of it came from the chlorine? So where is the chlorine in this working out? Hopefully you can find it's just there. So it's 142 in total, divided by 156 times 100, and you end up with, I'll do it with my calculator just to make sure. Okay, times 100, 91.0%. So it's 91%. Right, oh, sorry, do apologise. It's not 156. Well done for spotting that. It's 154 is the mass. So it's 142 divided by 154. That's better. 92.2%. So I'll just get rid of that. So again, make sure you're checking my working out as you go through this, because there might be some mistakes in there that, and if there are, just put it in the stream or the chat on the Google Classroom, and I'll get back to you as soon as possible. All right, and we'll start a brand new part of this topic on Thursday's lesson. So it's important you get all this done and dusted before Thursday. Okay, any problems, let me know.